All right, so in this last example, we're asked to solve a matrix equation here. So we're going to solve AB equals C. A is a 2 by 2 matrix that we've met already. B and C are column vectors. We can think of them as matrices as well. They're 2 by 1 matrices. We're going to solve this equation using an inverse matrix, and we're going to get the values of x and y. So I'm going to write down the inverse matrix of A first, because that's what we found in the previous question. So if I just make a note of that, so A to the minus 1, as we found, was, just swap those elements, so it's going to be negative 1 over 11, 3 over 11 there, negative 2 over 11, and negative 5 over 11 there. So you can check that if you like. Now, in order to solve the equation, we've got AB is equal to C. I'm just going to write that down. So just leave a bit of space there. We're going to use the property of an inverse matrix. So remember an inverse matrix. So I'm just going to write down here. If I take the inverse of A, multiply it by A itself, I'm always going to get the identity matrix. Okay, and this will be a 2 by 2 identity matrix in this case. This is also equal to A multiplied by its inverse on the right hand side. And what's important about this is the fact that the matrix multiplication in this instance is commutative. If you're multiplying a matrix by its inverse, it's commutative in this case. So if I take the inverse of A and I multiply it on the left-hand side on both sides of this equation, we can use this property because we know that on the left over here, the inverse of A multiplied by A is just going to return us to the identity matrix. And multiplying any matrix by the identity matrix is just going to leave it unchanged. So the next step would be, if I'm just going to bring this up here, the A to the minus 1 and A will just cancel out. So we're going to be left with B on its own, which is what I want because I want to solve for x and y, and that's going to equal the inverse of A multiplied by C. Great. So let's fill in what these matrices actually are. So B, of course, is x, y, like that. A to the minus 1 we have, so that's negative 1 over 11, 3 over 11, negative 2 over 11, and negative 5 over 11, like that. All multiplied by C, which is negative 1 and 7. All right, so we've got to do some multiplication. So we're going to multiply the top row by the first and only column. Let's see what we get for that first entry. So we're going to get 1 over 11 plus 7 times 3, which is 21 over 11. So that's going to be 22 over 11, which is, of course, 2. Okay, you can check that on your calculator if you like. For the second entry, we are going to get, so let's just multiply that second row by the first and only column. Now this time we're going to get 2 over 11, subtract 35 over 11. That's going to give us negative 33 over 11, which, yes, is equal to negative 3. So we've now got an equivalence. Now we've got x must be equal to 2. All right, and y is equal to negative 3.